Okay, just a quick check for where you're at so far. Have you figured out the parent graph?
Yes.
What is the parent graph? 2 to the power of x. So if we do a quick sketch of it over here, it has 0, 1, 1, 2, and your asymptotes. And just to make sure that you're going good from left to right. So maybe you like that idea of highlighting the 2 and highlighting the x, so that you don't mix them up and you don't think of them as transformations. Going from left to right, the first number we run into is a 3. Vertical or horizontal? Vertical. Okay, again, maybe you put everything in the exponent in a red box so you remember that everything inside the function is horizontal. Vertical stretch or vertical compression? Vertical stretch. You're going to multiply your y values by 3. The next thing you run into is the negative. The negative is horizontal what? Horizontal reflection. You're going to multiply your x values by a -1. That's going to flip it over the y-axis. And the last number we run into is that 2. Horizontal or vertical? Horizontal. Horizontal translation. Are we going to go 2 to the left or 2 to the right? Okay, everybody's saying 2 to the left because you see that +2. In fact, this one is 2 to the right. Why? Because we forgot to do something that's super important. What did we forget to do? Whenever we had, remember this note, whenever we have a horizontal stretch, reflection, compression, and a horizontal translation, it has to be written in factored form. Our first example that we did here, notice I was nice. I gave it to you in factored form. The textbook, not so nice. It didn't know you when it was published. It didn't care about your feelings. It didn't write it in factored form. So we have to factor out the negative, which leaves us with x -2, which explains why it's 2 to the right. So I wanted to make sure we talked about that because I would say there's what, about 99.9% of you that wanted to go 2 to the left. Okay, now I'll let you keep graphing. Here. So starting with your points 0, 1, and 1, 2. We'll write our asymptote down here at the... If you do all your stretches and compressions first, you would have y by 3 and x by a -1. This will still be 0, y by 3 will be 0, 3, and -1, 6. And then finally, all of our translations, we only have one translation, and that's 2 to the right. So you'd have 2, 3, and 1, 6. And what happens to our asymptote? It stays the same. So when we go to graph this, we always have to draw our asymptote. So one thing that happens often is that when your asymptote is on your axis, sometimes it's hard to see. One of the things that I recommend is bring a red pen to class. Use your red pen for graphing asymptotes. So on a quiz and a test, take out your red pen, draw your asymptote in red. That way it's easy to see. Because sometimes people say, when I put my pencil over the axis, you can't see it. Will I lose a mark? Yeah, you might lose a mark if they can't see it. So taking out that red pen and showing it, especially when it's on an axis, really makes your asymptote pop out. Now we have 2 points. You have 1, 6. Draw that point and label it. 2, 3. So based on where those points are, your graph is going to be swooping down like this. Wow. Should make my points big enough. Oh, perfect. It went through them just nicely.
Well, that's what I do too when
You make your points not. So now we can answer the other question. Is it increasing or decreasing? Well, this one is decreasing. What are the intercepts? Well, if I look back at my graph, I don't see any intercepts on here. I know that there's no x-intercepts because of the y equals 0. But I can't tell, because I don't have it labeled, where my y-intercept is.
You set x to 0.
Exactly. How do we find a y-intercept? You set x equal to 0. So if we go to our original equation, and you set x equal to 0 to find your y-intercept, you're going to get 2 to the power 2, which is 4. And then you're going to multiply it by 3. So your y-intercept is 12. The equation of the asymptote didn't change. It's still at y equals 0. The domain of all of our exponential functions is always everything. The range can change, but in this case, based on our final, oops, no equal sign there. Based on our final graph, our y values are bigger than 0.